y equals x plus 1 bracket squared times x minus 2 bracket squared. So we need to sketch this. So let's have our axes here. Now, we've got the highest power of x is power 4, isn't it, when you expand these brackets, and in your mind's eye you see x to the 4. So here, as x tends to infinity for x large, the power 4 will just make y power 4 will get very large, and x tends to minus infinity. Y again, power 4 of minus infinity will still be very, very large, so it's going to come down from up here and go back up there on the negative side. So there's our two guides then, as x gets large positive and large negative. We can see that this is squared and squared. Let's get the roots first of all. So y is 0 when x is, so here y equals 0 when x equals, or put in minus 1 in here and you'll get a 0. And put in 2 here and you'll also get a 0 times something which is 0. So minus 1 and 2 and 2. So now the other thing to observe also, y, because this is squared and this is squared, y is always going to be a positive number greater than or equal to 0. And that's true for any value of x. So that's true. So clearly then it equals 0 is going to be the minimum. So it's going to shoot down to the minimum here at 2, shoot back up, hit a value here, shoot back down, and go a minimum here. We don't know whether the maximum, you would think it was over here, wouldn't you, the maximum? So what value is it when it's 0? You get, so when x equals 0, what does y equal? Put 0 in here, you get 1. Put 0 in here, you get 4. 4 times 1 is 4. Minus 2 squared is 4. So 4 times 1 is 4. So that's where it goes through. 4. So I'm going to try and draw it now. So I'm going to do something like this. I'm going to come down. I'm going to go back up. I'm going to come back down, and I'm going to go back up. The only thing we could do is get this minimum here that we don't know by differentiation if we wished. But I'm not going to get sidetracked on that long-winded approach here. Y equals x plus 1 squared, x minus 2 squared. Let's just check it then with our plotter. So we want x plus 1 squared and x minus 2 squared. X plus 1 power squared times x minus 2 power squared. X plus 1 squared times x minus 2 squared. We'll go from, say, minus, because the root is at minus 1, let's do to minus 2 at least. And then, because the other root is 2, let's do to 3, say, in the first instance. Just have a little look at that. Yeah, and that's what we thought we'd get, didn't we? Nice little curve like that. So that's good. And you can see where the maximum is here. You could find the turning point by differentiation, couldn't you? Let it equal 0 and find the roots, if you wished. This is clearly the minimums here that we said by inspection of this property here, that the y is always greater than or equal to 0.